All right, we are now recording, right? So the video is recording, audio is on. Okay. So here we are. Okay, so as you can see, the topic for today is SA and security, or system administration and security. All right, so we're going to go over that today. So system administration, basically, there we go. All right, sysadmin and security. And you guys, you guys know a lot about security. You take a lot of courses in that related to that, obviously. So you probably are already familiar with a lot of concepts. We'll talk a little bit about some of these today. Let's move on. So, the very first thing is okay. I did not say that the account management was extra credit, right? I said that that's the last lab, and then the firewall labs is extra credit or bonus points. All right, so user account management is your last lab that is due. All right, so now, so anyway, are you paranoid enough about your systems, right? That's really ultimately the mentality that you should have, right? So I said you're the system administrator, and you need to have obviously a security system in place, right? So some kind of an approach, and so that's a general thing from a point of view of a system administrator, not necessarily a technical thing, right? But it starts from an overall managerial approach, and then it starts to get specific as you start to look at the individual technologies. Okay, so a couple of things to consider. So one of them is, of course, just considering disasters in particular. I know you guys take a course, 352, I think it is, which deals with some disaster recovery. So I'm not going to cover that in so much detail here. You can just read through it. But disaster recovery just deals with, the things that can happen, right? So a lot of catastrophic things can happen. We can start there before we start thinking about hackers or anything like that. We can think of, natural disasters or technical things, the pandemic, right? Something you never thought about. And it's anything that can disrupt your IT practice is certainly something to be concerned about. So, things that can happen, fires and earthquakes, lightning and tornadoes, hurricanes, so basically you want to figure out, you want to think of all of those things, and then you want to define, what are the things that you can lose? And usually what is the loss? And usually that relates to the assets, right? So you think of in terms of what are the assets that you're trying to protect, and those can be physical assets, but also, tangible and intangible. So they can be physical, or they could just be, credit card information, basically data, etc. You want to consider your legal obligations, and then basically given that, you want to have some kind of a plan in place, okay? So your model really, you want to have an approach, right? So where do you start as you start to implement the security of your overall organization, okay? And so as you might think, okay, we're going to back up information, we're going to document everything, etc. But really, you want to know where to start. And the place where you should start is with something called the RCM model, or the risk and control matrix, right? And the risk and control matrix is basically a way that you can say, okay, we need to identify really a few things about our organization. Number one is, what are we trying to protect? What are the assets, right? The technology, the information, etc. Then you need to identify what are the threats to those assets, kind of like the example of, you know, these, right? So Mother Nature, but also other things, hackers, etc. And then once you've identified those, you want to, you know the assets, you know the threats, you need to identify some level of risk. And then once you've identified some level of risk, then you want to identify, okay, what are the controls that I need to have in place? So for instance, if you talk about your Unix systems, maybe one conclusion is that you should have as a control a firewall, okay? A system firewall, okay? So that's basically where you begin, and we'll, you know, I'll talk a little bit more about that. But as you start to do the analysis, you start with a risk and control matrix. This is just, you know, think of it as a binder with some documentation. You start to lay out everything, you know, do a little bit of cost analysis. From there, then you start to create policies, okay, policies. And this is still something that is not technical, but it's just managerial. Okay, so you have, you know, your security policy over here, right? That takes us to what you need to have in place in your organization. And security policies are now that you've done the risk assessment, they're just basically, you start putting in writing everything that you want addressed about your organization, okay? So that's, you know, kind of one of the steps. So as I was saying, so you start with you do the risk management and you identify what risk is, okay? So you identify risk. And so you say risk is the relationship between your assets, the vulnerabilities, characteristic to those assets, and the attackers who wish to access or modify those assets, okay? So you start to quantify this information, but it all kind of revolves around this idea of assets. Okay. So the assets can be, you know, a login account, the network bandwidth, disk space, the data itself, the reputation of your organization, the generators that power things, the servers, the routers, etc. Right? So a lot of things can be assets in your organization. And then you remember from your 350 class, you should probably remember this, that the assets are, you know, there's a set of security goals that we need to have in relation to those assets. For instance, for data, we want to maintain confidentiality. We want to maintain integrity of the data, right? We want to maintain availability of our servers. We want to have authentication, etc. All those principles need to be in place, okay? So you can see examples here of availability, integrity, and confidentiality. So once you identify the assets, then you can identify the threats that are in place. You know, what are the threats to those assets? You know, they can be a lot of things, you know, phishing, spam, you know, censoring, personal motives, revenge, you know, lots of things, right? Lots of things that can threaten the security of your assets, basically. So you identify that what are the vulnerabilities, you know, what can happen, how can they be exploited, right? And then you start to think about the defense types that you're going to have in place. And these are usually, the generic term for these is controls. What are the controls that you have, excuse me, that you're going to have in place, basically? So in particular here, there's a principle called defense in depth, which is basically means that, you know, you need to have security systems at all levels, okay? So you have security at the network, you have security at the host, you know, you have device hardening, intrusion detection systems, malware tools, etc. Right? So you guys are familiar with a lot of these, which are the tools that you have, the technical tools that you have in place to protect your environment. However, controls aren't just technical. They could be simple things like having a, in the policy, right, that anybody that did something or something else, you know, could be prosecuted legally, you know, all those things can be controls. The sign-offs, sign-offs of a specific form that somebody says they're responsible for updating that server, and they sign off on that. All that can be the controls. So these defenses, the goal is to mitigate these vulnerabilities, or et cetera, right? So you have all these tools, which I've already mentioned. And then I talked, as I said, the starting point is the risk and control matrix, which is, basically nothing more. You can think of it as a table. You exhaustively identify all your assets, all your risks, all your controls. Okay, so you want to have those in place there. Okay, and identified. And from there, you start building everything, policies, putting controls in place, and then you want to assess them as well. So examples of security policies, there's like user level. For instance, users must sign before receiving resources. You can have policies on the acceptable use of the web or the email. There's a monitoring and privacy policy. There's a remote access policy, etc. There can be a lot of policies. And these are just, as I said, just simple generic documents that stipulate some of the terms of the business. Network connectivity, log retentions, etc. So this could be a lot. This can be many, right? There could be many types of policies in place. And from the risk and control matrix and from the policies, then you will start to dive deeper into what technical solutions you will need to have in place. Okay. So for instance, some of the technical solutions that you guys are familiar with in relation, let's say, to Unix, for instance, as an example, we can think of this as a Unix example. Okay, and what are some of the OS hardening things? Use sudo, right? You guys know what sudo is. You check the logs regularly. You're familiar now with logs. Secure the physical system in a secure place. Install only necessary software. You guys are familiar with that. Keep the security patches up to date, so update your system. Delete or disable unnecessary user accounts. You're working on the user account lab that shows you how to do that. Using secure passwords and having a policy that enforces secure passwords, where you have characters, numbers, specific length, etc. Disable remote access, for instance, disabling telnet, right? You want to disable telnet, but maybe SSH is available to some people. You configure a firewall on each host, right? So most hosts have firewalls. As I said, this week's bonus lab talks a little bit about that. Every now and then, run a security scanner to check for security vulnerabilities. Document your security configuration, maybe by writing scripts, right? Maybe you have scripts. Maybe you have scripts, and the scripts will allow to serve as a type of documentation for your environment. Okay. Okay, so that's a physical system. Obviously, there's as a sysadmin, you have to worry about place the server in physical secure location, lock the door, physically secure the case, place ID tags on all hardware and keep track of them, in some database, disable booting from removable devices, etc. So there's a lot of things that you put in place to physically secure the system. And then, this just goes deeper into like checking logs, security auditing, right? So that's can be internal or external. So that means you as the system administrator do this periodically, or an external team is hired, right? An organization, and they come in, they do an audit of your systems. They can basically audit for compliance with the security policy. They can check the physical security of the network. They can check that machines have up-to-date patches, scan networks to verify that all hosts and services are there, and do what is called penetration testing, pen testing, to make sure there are no vulnerabilities in the systems, right? So a lot of these things can be done as part of a system administration practice. We talked about disabling remote access. Sudo, you guys know what sudo is. That, you know, so to have accountability, you discourage the use of root, right? And then instead, you just have a sudoers group, and then you add accounts to this so that your administrators can have root privileges, but they have to use their accounts. So then you're tracking how they are, who it is that's doing things in the systems or in the network, etc. Okay. All right. We talked about that, some examples. Linux, as I was saying, the host-based firewalls. We will talk about this today. So Unix basically has a firewall. And the firewall is called IP tables. It's a very powerful firewall. Very, very powerful. IP tables, right? And but it does require a little bit to learn. However, IP tables has what is called the Ufw interface. And the Ufw interface is a command line way of accessing IP tables. It's easier than IP tables to add rules into the firewall. So you can, you can do things with it, like blocking IPs, blocking ports, blocking incoming or outgoing traffic. So lots of things can be done with this. Okay. All right. So so that's host-based firewalls is one of the tools in Unix. All right. So given that we kind of just talked briefly about how to start with security and sysadmin, now we can lead in specifically to firewall, the topic of firewalls in general. All right. So you can see here, firewalls basically can be network firewalls or host firewalls, right? So in this case, imagine that this is your internal network, and then you have here maybe a Linux server, right? So this would have, if it's a Linux server, it would have IP tables running on it, which is the the firewall. But you can also have what are called network-based firewalls, such as this one, right? This is a network device that has two network interfaces. So basically, it's initially acting as a router, and then you kind of, it routes traffic from one network to the other. Like this could be a 10.0.1.0 network /24. This could be a 10.0.2.0.24. So it's a device that's going to route traffic, but it'll have, if it has the additional functionality like IP tables, then it is a firewall basically. So there are two types: network-based firewalls and host-based firewalls. So for our class today, or this week, we're going to focus mostly on host-based firewalls, but just be aware there are two types. So the key thing is that a firewall has what are called ACLs, or access control lists, rules basically, rules that are implemented, and whenever a packet hits the device, it'll be analyzed or compared against those rules, and then basically a decision is made, such as, do I let it go through? Do I accept it? Do I drop it? Do I reject it? Do I log it? etc. So a lot of things can happen. Now keep in mind that the firewall is in between you. Let's say you're at home, so it's in between your TV and your Netflix, right? So I give this example. So the firewall can't be very slow, because if it's very slow, then your Netflix, it'll take an hour for it to download for you to watch, and that doesn't work, right? So this needs to be done at a very low level and in a very, very efficient way so that it doesn't affect performance. So the need for firewalls. So, as you know, internet connectivity is essential. However, it creates a threat, right? So you have to protect your local area networks. And so basically you're going to insert a device between, the less trusted outside internet and your internal internet, okay? So this can be a single computer system or a set of 2 or more systems working together. So as you saw before, we actually have one firewall here, and then we have a router, but the router can also have access control list. So very much it can do some type of firewall functions, okay? Firewall functions. And, a firewall like you could build using a Raspberry Pi or just any Linux server. You could build your own firewall from Unix. Unix is a very powerful, versatile device, so you can easily build your own. You just need 2 network interfaces. Okay. So you can use it for perimeter defense, or you can use it locally to protect your systems. Firewall characteristics, the design goals, all traffic from inside to the outside must pass through the firewall. Only authorized traffic as defined by the local security policy will be allowed to pass. So that means, if you have, the internal network, and then this is the external or less trusted, right? You have ingress and egress. So ingress, this basically means all of it is allowed out, but it must run through some rules, right? Now, techniques used by firewalls to control access and enforce the site security policy are service control, which basically means what? Looking at services, right? So that's one of the things you learn in this class is services like, SSH. What's the port number for that? 22, right? FTP, HTTP, and so on, right? So firewalls work at that level. They usually work at looking at the port number, destination port, source port. They look at the direction. Is it ingress or egress? That's really important. Some type of control of who it is by ID, IP address, etc. And also sometimes a little bit of behavior. Like if you have a denial of service attack and you're getting too many SYN packets in a second, you can stop all traffic going forward. So usually the UFW firewall, most common firewalls will be what are called packet filtering firewalls, okay? Packet filtering. Okay. All right, so packet filtering firewall applies rules to each incoming and outgoing IP packet, okay? Typically, a list of rules based on matches in the IP or TCP headers, right? So you guys probably remember that from your networking classes. And then basically it makes the decision to either forward or discard the packet based on each rule. So if there's a match, it decides whether it's gonna let it go through or not, okay? So the filtering rules are based on information contained in the packet itself. So that can be the source IP, destination IP, source port and destination ports, the protocol, right? The interface, etc. Right? So lots of things there. All right. But usually I should say what's missing from that from this is if you remember what a packet looks like, right? So we know like a TCP packet's got Ethernet header, IP header, right? TCP header, and then a payload. If you look, the firewall usually does not look, it'll look at this, but it does not look at the payload. And the reason for that is that would seriously slow down the traffic. Also, sometimes this is encrypted, right? If you have certain encrypted communication, so you can't really look at it in that sense. But also, especially if it's a network firewall, but also this, because of performance, that might be an issue. So the advantages and weaknesses, advantages, simplicity, typically transparent to users and very fast. Weaknesses, it cannot prevent attacks that employ application-specific vulnerabilities or functions, right? Anything, as I said, at the payload level. And it does have some limits like logging, etc. Okay. Stateful inspection firewall. This is a different type of a firewall that keeps track of information. So tighten rules for TCP traffic by creating a directory or a table of outbound TCP connections, right? So it keeps a table basically. There's an entry for each currently established connection, right? So, like when you do netstat-na pipe grep TCP, and you see the list of established connections, right? So similar to that, you have established connections in a table, and you're keeping track of connections that are already made. And so that type of a firewall is called stateful inspection. The packet filter allows incoming traffic to high number ports only for those packets that fit the profile of one of the entries in the directory. Okay, it reviews packets information, but also records information about the TCP connections. So you can see here a stateful firewall example. You have, this is the firewall itself, right here. We have a trusted internal network computer, right, in the 128 network. Then we have some server outside of the network, right over here. We have an attacker also in the web. Right, so then we have, then we have, let's say client wants to communicate with the server, so it's a TCP connection, so there's going to be a three-way handshake, so the SYN-PAC, SYN-ACK, ACK, right, between these two servers. So basically what happens, the firewall knows this was initiated from the client, and all traffic is going to be tracked through an established TCP session, which is a combination of the IP of this one and the IP of that one, okay? So you know that they've established a connection, and now you filter, right, all that traffic, but you're keeping track of the fact that it is an established connection, okay? Here's an example of, sessions, right? So you have communications, the source add IP and port, destination IP and port. Okay, but it's still, at the end of the day, you're just checking all the traffic and matching it to specific rules. The only difference is that you have this intuition that it initiated from the inside, so there's a little bit more trust there for that connection. Okay. Host-based firewalls, your lab, your bonus lab, I should say, if you wish to do it, is basically, it doesn't even look at IP tables. It only looks at the interface for IP tables called Ufw, and therefore it is a host-based firewall, right? It is, in fact, the Unix standard firewall. Okay, so used to secure an individual host, as you guys know. It's available in the operating system, or it could also be added. Some of you probably, I'm sure, in Windows have installed maybe an external firewall, although usually operating systems come with their firewall. So it's a similar idea. And then, it's used to filter and restrict packet flows. What are the advantages of having a host firewall? Well, filtering rules can be tailored, right, to the host. So it's, you're only concerned about things that might apply to the host. So a Unix. So for instance, a network firewall may need to worry about Windows and Mac and Unix, or smartphone or other devices, right? Whereas a host firewall on Unix only needs to worry about Unix-related issues. So that's one of the advantages. Okay. So you don't worry about the topology of the network. Obviously, it's only individual to the host. And it's a layer, and it's an additional layer of protection because you're assuming that your network has a firewall. So there's the network firewall does provide some protection for the host, but also the host-based firewall provides that as well. So here we have an example of a network of what we're talking about. So as you know, there's the internet, so less trusted environment. There's a router. Then there's a firewall. There's a switch, another firewall, and another switch, right? So you can see that this is basically the DMZ, right? So this is, you can see that there, the DMZ. And what that implies is that this firewall is more restrictive, right? So this one is, and what that means is basically it has fewer open ports, it's got more rules, where this one does allow traffic. Possibly it's got port 80 open. Why do you want port 80 open? Because here you have the web server. So people from the internet, want to access the web server. There's email servers, DNS servers, etc., that need to be accessed from the outside. But as you get past this firewall, it becomes more restrictive because this is really like the inside of your network, right? Where you have your employees working. So here you have, workstations, applications, etc., used to do the work of the company. Okay, make sense, guys? Any questions so far?
I don't think so.
Pretty easy, right? All right, so let's continue. So as I said, we're just going to do a lecture on this, and then I'll go over the lab in case, I'll still talk about it, even though it may not be, it's not required. It's bonus. All right, so now we talked a little bit about that. We'll talk about ingress and egress. So in particular, whenever you have a firewall, think of it this way. Right, and let's say this is the inside and this is the outside. The outside just means the side closest to the internet, right? And so this is called ingress and egress, right? So egress is this direction, and then ingress is this direction. So obviously egress is allowed because, that's how you, whenever you want to do anything, open a browser on your computer to read the news or check your email on let's say Google or something like that, you're going to egress from your computer, right? So that's usually allowed. Ingress, on the other hand, is usually not permitted. No ingress is allowed. What that means is that, now of course, if you initialize from here, then a return traffic is allowed. What ingress means is traffic that originated outside. It wasn't initiated by you, but it's, something in the web or wherever tries to access the inside. So the firewall has very strict rules on ingress, okay, that it doesn't allow, so block all in from IP or block all in basically, right? It doesn't allow it unless it's something that initiated, but then you have some kind of a established sessions, right, that can be allowed in, what we saw with the stateless. Okay, so that's basically the definition between ingress and egress, and it's pretty important. So this one, egress is allowed. Ingress, when it initiates from the internet, is not allowed in. Okay. So here's a classic example of a network, right? We have, you know, domains of trust, right? So this kind of underscores the idea of domains of trust, where we have, think of it this way, right? So like if I do this, like that. So this is the less trusted. This would be the internet web, right? So here we have a router. It can have ACLs, but usually the ACLs are less restrictive. For instance, port 80 might be open because here you have, you know, let's call it a web server, and you want to access those files. However, the firewall will not allow things that originate. You could ping probably all the way to here, but you're not going to get past this because this would represent the inside. You can see that there, the inside of the network. Okay, and then as you get to a computer, let's say this is running Linux, it's just a host. This would also have its, you know, Ufw firewall. Okay, so that's, you know, that's an example of a network and firewalls. Now keep in mind, there's a lot of other services, and pretty much all services provide a little bit of security or control. All right, so keep that in mind for the exam, for instance, the final exam, how you know, how things can be, how all services, etc., work together to provide a little bit of security for your environment. Okay. Here I provided just an example of how to configure you know, these devices in the network. I'm not going to go through these, but you can read through it if you have curiosity about it. So it goes, you know, along with a lot of steps on how to do the configuration. And these are Cisco devices, by the way. So this is Cisco. But I'll just skip this part and leave it for you to read if you have an interest in that. All right, so now let's just talk a little bit more about ACLs and filters. And here, so I'll talk just briefly about some of the rules. You can see here at the end, I have some rules there. And then those, again, these are just Cisco rules. Then we're going to look at IP tables rules in Unix. All right, sorry. So ACLs and rules. So obviously, whenever you talk about a firewall, right, you talk about a firewall. Ultimately, what it comes down to is that you talk about rules. What are the rules that you're going to put in place in there? You know, and the rules deal with the direction of the packet and then some of the values, some of the headers in the packet itself. Okay, so that's what ACLs are, access control lists. But you can just think of them as filters. Okay. So whenever we think of an environment, one thing that you want to think about is domains of trust. And what that means is that you kind of start to classify your network, right? You kind of classify your network based on the areas that it has that you perceive to be a little bit more secure or a little less secure. So you can see here, high trust is this, and no trust is that one, right? So for instance, here we can see, you know, obviously the internet, right? So very low trust domain. Then we have an external server, which could be like a web server, right? And then we have a higher trust domain, which is the connection to your user PCs, internal servers, and then even deeper into your network, your finance and payroll servers. So if you think about it, the way to do this is we have, you know, a router here, and then here we have a firewall, right? So this is connected to some kind of a switch. So basically we have that, this is the internet, and then this just represents, you know, all the computers there, right? So if you think about it, that drawing that I just did is exactly, you know, the one that we had here, right? So look at how the evolution of it goes, right? So you divide it into the trust domains, but ultimately, this is the firewall. No, sorry, that's a switch. This is the firewall. and then this is the router itself. So you start to separate, segment out your networks based on trust, right? You can even have another router in here to kind of further even deeper. Okay, so common domains of trust, you have the internet, right? Public servers. So anything that can be accessed from the outside is a lot less secure. Then you have your WAN or VPN connections to business partners. That starts to add more security. Remember, this provides authentication, encryption, etc. Then you have remote sites and remote users, right? Like you guys might be remote somewhere, but you're using some type of a service, hopefully, VPN. And then you have your more trusted environment, like your basic internal network, department-specific networks, and then things, additional things that might be in a data center or something like that. Okay, so the idea though is that you identify your domains of trust, and then you use devices to segment them out. So this crude drawing that I had here, right, which is not so great, is really, that one a lot much better, right? So now we have, again, though, the router, the firewall, and then the internal network over here. But at the end of the day, the point is that the device that allows you to do all this is a, let's just say a 2-network card device that forwards. This can be a Unix device, right? You can easily make your own router, your own firewall with a Raspberry Pi, with a Linux machine. You just have to make sure you don't necessarily have to buy an expensive device. Although those, you need to have the RAM, obviously, and the CPU for it. All right, so that's, the general idea. And as I said, from here, from this idea, we kind of evolve into this idea, which we kind of evolve into, like this idea that I drew. Okay. So when we talk about, as I said initially, when we talk about firewalls, at the end of the day, we end up talking about filtering, basic filtering, right? So just some rules. Usually referred to as access control list. Access control is central to Unix. We've set that from the very beginning of the semester. So they're usually very easy to implement. When you have something like this is very much like your home environment. Your home environment, right? So you guys have, your ISP, and then this is your internal network. So public servers are on. Now the problem is, if you want people to access a server that you have in here, this is problematic, right? Because then you're going to have to open a port here, port 80, maybe do port forwarding, those kinds of things. And if you're doing something like that, that's going to be pretty insecure. So this is certainly the basic approach, but it's not one that you want to follow necessarily, because you have to open ports, use port forwarding, etc. A better one is to take, if we talk about network firewalls, take what is called the classic dual router DMZ. And what you do here is you have, again, this is the internet, so the less secure. And then you have 2 routers. And then you have your web servers here. So this has port 80 open, for instance. But here, so port 80 is open. Here, port 80 would be closed. So nothing gets through this one, or very little gets, or less gets through this one. A more secure way of doing this is obviously to use a dedicated device, what nowadays are called, firewalls, or even more advanced, ASA, which I think are called advanced security appliances, whatever commercial name they're using nowadays. But these are just provide more services, right? They provide filtering. They also provide other services like VPN and so on. Okay. And that's from here on, you can, these are just additional diagrams of more complex. You can read through these if you'd like. So there's also a type of firewall called a content filtering firewall. And this is the firewall, as I said, one issue with a firewall, especially in the network, is that you know, I'll give you the example again. You want to watch your Netflix, right? So you have your TV, and then here's Netflix. If you're looking at everything in the packet, which means you're looking at not just the Ethernet and not just the IP and not just the TCP for TCP packets, but you're also looking at the payload, you're really going to slow down your communication, right? Your network traffic. And so maybe your movie will start in an hour, so that may not work for you. So firewalls then usually don't do payload, right? However, you can have payload evaluation firewalls. Usually these are called content filtering firewalls, or proxy sometimes, proxy firewalls. For instance, Unix has a firewall called Squid. And what that does is that in the network, you have another server, a Linux server, and you configure your network so that whenever you're going out to the internet, instead of doing that, now you need to go to this server and then back out. So your traffic goes into ports open in this device, and this device will provide filtering for you, okay? So that's a different type of firewall, but that can also, it's relevant to Linux because it can be implemented for free in Unix, okay? All right. So you can see, you know, kind of the drawing that the crude drawing that I made before. It's a little bit better here. So you have the internal network, you have a device, right? And usually the device would just go like that. But with a content filter, the system is configured to first go here, and it only gets through if there's going to be rules here that check. And this is more for the application layer. Now, this can also be good in the sense that the packet still goes out, but you issue some kind of an alert or a log or something along those lines. Now, the last part of this is we're going to take a look at just, as I said, what are some of these rules, right? What are some of these rules? So in the past, there's been a lot of filters. These were usually just filters. Nowadays, in Linux and Cisco, other firmware, it's usually just one set of rules that you want to use. And so we'll take a look at that. The basic idea with a rule in a firewall is you want to control, so you want to provide access control by looking at specific parts of the header. And usually the focus, this is a packet, the focus will be on either Ethernet, IP, like the MAC address, right? So Ethernet, IP, or header TCP, it could be ICMP, UDP, and so on, right? So, but usually you look at things like the source address, destination address. You're going to look at the protocol. Is it IP, TCP, UDP, ICMP, source port, destination port, right? So, and combinations of that. In the lab, I'll provide a few more examples of this. But in general, this is what you do. And this is both at the network or at the host base, depending on the types of firewalls that you are creating. Okay? All right. Sorry. Okay, so here we have, so basically what do you do with a packet? So packets are usually either accepted, they are dropped, or rejected. Rejector is pretty much the same thing as drop, except that the device usually tries to issue a message. Like when you ping, and if it says rejected, it might give you something, type of a reason for it, okay? All right, so here then, using some kind of a network device, like a Cisco device, you can see that the rules are pretty straightforward. There's usually you say things like permit, protocol, ICMP or UDP, then the host, specify the IP address, you might specify the net mask, and then where the service equals some number. or you use keywords like any. So for instance, for ping, you might say permit ICMP any, which means any IP, any port, if it's an echo request or an echo reply or something, right? So that's the generic way to think about firewalls or firewall rules, okay? That use, basically a one-line command that provides information about what to look for in the packet, and then basically decide, do I allow or do I drop or what do I do? Okay. So here's an example of some, again, some other rules. So you might say, sorry, yeah. So, you assign some IP address and net mask to an interface, etc. So we'll see this more specifically as it relates to, because these are Cisco commands. So we'll see something that's a bit more specific to IP tables in a second. Okay. But in conclusion, usually when you're talking about firewalls, you're talking about these rules that you're trying to implement. Okay. All right, so let's see what else. Now VPN, we're not going to talk about this yet. I do recommend that you take a look at this. VPN is a service that's important, right? You might need a VPN. Now, when do you need a VPN? Let's actually go back. Let's see if I have a. I thought I had it, but let me go back to here. Perfect. All right, so let's talk about VPN. So what is VPN? It's a virtual private network. What does that mean? It means that, let's say you have a remote worker. You have a remote worker and you're working from home, right? So this, of course, is the inside of your network, your company, right? And you have here, there's an FTP server that you have to access to do your work, whatever it is. So how do you get, as a remote worker, into that server? Well, as we said, this is, let's say, a web server. So we know that we can probably, from the internet, ping all the way through there, even through there. But we're not going to get past that because that's the firewall, right? So the firewall will not let us get through. So what you do is you're going to need to have some kind of a program, an application called a VPN client on your laptop. And then the VPN client will go there, right? And it hits that outside port where this device will host VPN. It's a firewall, but it also has VPN services. Okay? So then what's going to happen is when you hit this VPN service, you're going to be authenticated. So you need to be authenticated. And then also you're going to use crypto, public-private key infrastructure, all that stuff to authenticate and then to provide confidentiality. So you can create a secure connection. Once you do this correctly, basically you end up with an IP, let's say, of the inside network or the VPN network or your company. And at that point, you can access the FTP server. However, if the connection is broken, right? If the connection is broken, you will not be able to authenticate. Now, another thing that happens is usually here in the internal network, you'll have something like a domain controller with Active Directory services, right? So there's also in this domain controller, there's Active Directory, and then there's something called Radius Server. Radius Server is a network-based authentication tool. So what happens is, if you want to think of it as, let's say you're coming in with a VPN, right? You want to access this FTP server. So first, you come in and you authenticate. So the network device will authenticate to the Radius server, right? And basically say something like this device is available, it can access the network. But then also you need to provide a username and password. And usually when you send the username and password into the VPN will forward that username and password to the domain controller and to Active Directory services where you have you know, a list of users, right? So that type of authentication is usually done through the firewall itself. So the configuration can be done there. So anyway, so in essence, you know, as I said, to get access to the internal network, VPN is a very complex tool that authenticates you and then encrypts all communication. But it basically makes it look like as if you were inside the network and can access the resources. Okay? So that's kind of the gist of it. You can read more about it just by going through this set of slides. It goes into more detail about it. And then finally, the last slide I will talk about of these slides before we move to the lab is this. Oops, I did not want to do that. Hold on. Sorry. So the last slide I'm going to talk about is this one. So just for the exam, I would recommend that you think about, look at this slide, okay? Look at this slide. And in particular, try to understand this network. And it's just identify most of the services that are here, okay? So if you look, for instance, you will see that there's some wireless access points. There's some workstations, right? There's a firewall over here, some kind of a router. You can see there's, you know, more routers here. You can see there is a like a data center area here with computers. There's a VPN service there. You know, web and FTP server. And so the point of this is just try to identify in a network, could be this one or another one, what are all the services? So all semester we've been looking at services like DNS, right? We talked about, you know, HTTP, email, etc. So just try to identify and remember what are all the services that would be running, that could be run on Unix, but that can also support a network environment, okay? So that, you know, try to take a look at that, and because you might get a question about that on the exam. All right, so now that we've concluded with the slides, let's now go back to Brightspace. So let's go back to Brightspace. All right, and here in Brightspace, you know, we are in the course content of Brightspace. So you can take a look at, we'll take a look at this folder here. So as I said, you know, this is only a bonus points lab, but if you want to do it, we'll talk a little bit about it. So this lab has to do with, as you might imagine, with firewalls, but firewalls specific to the Unix operating system. So in Unix, you may need to, so as I said, Unix has by default a firewall called IP tables, but UFW is sort of a type of a command line interface to it. And the idea is that it simplifies entering the rules. And it does simplify it a little bit. The commands are a little bit simpler. And so the idea of this lab is it shows you how to use it. So it shows you, for instance, how to install UFW. It shows you how to enable and disable UFW. And then it runs through some examples. So for instance, if you want to block SSH, right? So first you start SSH here, right? You can start SSH, then you can block. How do you, or allow, right? So how do you do that? UFW allow 22. Why 22? Because if you remember, 22 is the port number for SSH, right? Now let's say that you want to block by IP address or subnet mask. Okay, then how would you do that? Well, you have to think of find out the IP, and then you'll change this parameter to an IP address. Okay. So this just goes through some of the configuration and how to. So you'll just follow the rules or the description here to implement some of these aspects. Now, there's also a built-in file called before.rules in the folder etc UFW. This file is useful, as you know, configuration files are stored in etc, and this is useful because you can go into that file and then just do the updates in there. So for instance, here you can see that currently these rules that you see here end with accept, right? And what that means is that they allow ICMP traffic. So what this is saying is go into that file, change the word accept to drop, right? And then you'll see that ping will be disabled. Remember, whenever you make changes to the UFW firewall, you'll have to disable and enable the device. Okay. Here's an example of how to block by IP. So you can see here, you say something like UFW deny from IP, okay? Or you can say UFW allow from IP, okay? So those are the rules. And then this goes into a slightly more complex scenario where you use a tool called Netcat. Netcat is a very nice tool for creating redirections in Linux, right? So you can work through the problem to try to implement some rules related to it. Okay, so I'll leave that to you. I mean, it should be a fun exercise. And then finally, you can even write some scripting rules. So I'm going to leave, as I said, this is a bonus lab. So if you want to get the bonus points, I'll leave it for you guys to figure out, but it should be pretty easy. I mean, all you have to use is subversion, right? So if you use a Python script with subversion, you should be able to insert and delete the rules automatically. And that's it. So it's a very short little lab. So it should be some easy bonus points if you want to do it. But as I said, this is optional and it's not required. And this is, the last topic of the semester. Okay. Are there any questions, guys?
I don't think so.
Pretty easy. So for, as I said, if we go back to the calendar here, you can see that, right? You can see that this week we're just talking about security and Unix host firewalls, right? All we have left next week, there's no more topics. There are no more new topics to cover this semester. And so all that's left is your presentations. So this Thursday, I'm going to just be there for open lab to see if you have any questions on your projects, if you want to demo your project. Oh, so at this point, let me actually stop the recording. So I'm going to stop the recording.